Okay, so number one says Mason deposits $9,000 into an account earning simple interest. So simple interest is the only type of finance problem that you actually have to use a formula for. It's not built into your calculator. So simple interest, there's two types of formulas. I equals PRT or A equals P times 1 plus RT. These are actually the same formula if you work it out a little bit. This way, if you're just going straight for the interest, like how much interest was earned, you can use that one. But this one works for every simple interest problem, regardless of what it's asking for. So if you're only gonna learn one, I would learn this one. So A is your accumulated amount, your new amount. B is your principal amount, or your old amount. R is your interest rate as a decimal. And T is time in years. And that's important because simple interest is usually given to you in weeks or months or days or something like that. So it says Mason deposits $9,000 into an account. So that's the original amount he puts in. And simple interest. What is the interest rate? So we're looking for R. If 4 months later, so our time is going to be 4/12 of a year. 4/12 of a year. And then the new amount is going to be $9,174. So these are just plug and chug problems. I'm going to put these in my formula. Put it all in the formula there. And my goal here is to solve for the interest rate. So I'm going to divide both sides by 9,000. Now I have 9174 divided by 9,000 equals 1 plus R times 4/12. Still solving for R. I would now want to subtract 1 from both sides. And so I have that all of this on the left equals R times 4/12. Solving for R, I would divide both sides by 4/12. This is going to give me R. The harder part on this is actually putting this in your calculator correctly, because your calculator likes to do order of operations for you. So I would suggest putting in just the numerator first, so 9174 divided by 9,000 minus 1. And I'll just hit enter. That's the numerator. And then divided by, you've got to put parentheses here, divided by parentheses 4/12. Because you're going to divide by the entire denominator. And we get 0.058 equals R. So as a percentage, that would be 5.8% interest.
What do the A and S stand for?
All right. Number 2, this is from chapter 4. So we want to maximize this objective function here subject to these inequalities. So when you're doing this using the simplex method, you don't worry about these bottom 3, or just where it's x is greater than or equal to 0. We don't use those in the simplex method. So the first thing you do when you're solving these is you rewrite your inequalities using slack variables. So we know there's going to be 2 slack variables because there's 2 inequalities. And so right here we would have 10x plus 5y plus 5z plus some slack variable, I'll call it s of 1, will equal 250. So it takes up the slack right there. And 2x plus y plus z plus some other slack variable would equal 600. So rewrite using slack variables. The next step is, for your objective function, you want to move everything to the left side. Has to go to the left side. So I'm going to subtract 30x and subtract 22y, subtract 12z. My p is going to stay there, And now it's gonna equal 0. So you rewrite using slight variables, you rewrite your inequalities using slight variables, you move everything to the left of the objective function, and then you can put this into the initial simplex method.
How you do that again?
Write it down. So I'm gonna label everything. We have X, Y, Z. And then we have an S1 and an S2 and a P. Right here, that goes below the bottom horizontal line, just the coefficients. -30, -22, -12. No slight variables on that one. 1, 0. And then I'll put my two equations, just the coefficients, in the middle here. All right, so now we know we're not finished because there's still negatives in the bottom horizontal, the bottom line. There's still negatives, so we're not finished. So we need to choose a pivot element. So you pick the most negative number in the bottom, and that's your pivot column. So we know it's column 1. And then you only take the numbers above it that are positive. If there was a negative or a 0, you just put an X beside that row. But those are both positive, so I'm going to divide them over here. 250 divided by 10 is 25. 600 divided by 2 is 300. You go with a smaller quotient, which is the 25, and that's your pivot row, which makes 10 your pivot element. And so our pivot element is in row 1, column 1. So once you find your pivot element, you now want to pivot. So this is where we can go to our calculator and type this in to a matrix. And so this would be a 1, 2, 3 by 1, 2, 3, 4, 5, 6, 7. A 3 by 7 matrix. Go to matrix, over to edit, 3 by 7. And then I'll type in my numbers.
Yeah.
Okay, once you get it in there, you're going to hit second quit, which is right by the second key. Second quit, you're back at your home screen, and you want to start your program. So you go to program, PRGM, and you have your Simplex program on there. So you hit enter, and it just pulls it up to the home screen. You hit enter again, and it starts running the program. You can tell it's running because you got a little circle moving right here, or you got a little line going right there. Tells you it's running. You select your matrix. I put mine in matrix A. And whoever wrote the program is giving you one last chance to double check your numbers to make sure you have them in there correctly. And then you hit enter to continue. If you typed something in wrong, this is where you would quit the program and go fix your matrix. If it's all correct, then you're gonna pivot. And it prompts you row 1, enter, column 1, enter. And then we decide we are not finished yet because there's still a negative on the very bottom row. So when you go to write down your new tableau, you just need to write down that negative row, which would be, or negative column, which is column 2 here. And your constants, so that's column 2. My constants were 25 and 550. And so this is obviously the most negative number, it's the only negative number. And then this is where you remember, you only divide the positive numbers above it. If either of those is 0 or negative, you're gonna put an X beside them. So that one's automatically gonna get an X because it's a 0. So you only divide positive numbers, so that makes this the winner. The winner is in row 1, column 2. And so we hit enter to continue. Hit it. Row 1, column 2. And you say yay, because there's no negatives in the very bottom row. And so I'm gonna write down my final tableau here, labeling it. Since we're gonna cross off any of the ugly columns, ugly meaning they don't have all zeros and one positive, like column 1 is gonna be ugly, I'm not even gonna write it down just to cross it off. I'm just gonna cross it off and say x equals 0. I'll write down the pretty columns. Z. S1 is ugly. So again, pretty columns have all zeros and one positive number. Everything else is ugly. So if it's ugly, cross it off and put those variables equal to 0. For the other ones, you're gonna read across row 1. So we have 1y, and keep going across, equals 50. So y equals 50. Row 2, we have 1 s sub 2 equals 550. And row 3, we have p equals 1100, and that is your maximum. Your p-value is always your maximum. Number 3 says, Cooper wants to be able to give his parents $1,000 at the end of each quarter for the next 5 years. How much money should he deposit into an account today at 2.75% compounded? So this is not a simple interest formula. That means it's a calculator question. Instead of using the other 7 or 8 formulas in this chapter, we could use our calculator. So I'm gonna write down over here what I'm gonna put in my calculator. And then things I know. He wants to give his parents $1,000 at the end of each quarter. So is he giving it to them once or over and over and over? So that's a payment. If it was once, that would just be like a present value type thing. So negative 1,000, he's gonna give them payments over and over and over. If you're paying somebody payments over and over and over, you're not doing this to have any money in the end. So your future value is gonna be 0. That's not your end goal. Your end goal is to pay $1,000 each month. He's doing this each quarter, so M is 4, because a quarter is 4 times a year, and that goes in 3 places. That's PY, CY, and N is M times T, so that would be 4 times. And if you keep reading, it says each quarter for the next 5 years, so 4 times 5. How much money should he deposit in an account today? So we're solving for present value at 2.75% interest in order to be able to make these payments. We shall go to our calculator. And our simplex problem is still running, so you gotta hit enter to continue, and number 7, quit the program. Then we can go to apps, finance, TVM solver, and we'll type in our stuff. 4.5. We'll come back and solve for present value. Payment, make sure you type a negative sign, not a subtraction sign. And putting my cursor back up on present value, I'm gonna hit alpha, enter. Alpha, enter. And I get the present value needed to put in today is $18,626.25. All right, so it says, since William turned 8 years old, he has been setting aside $1 every day. So keyword is every day. He didn't just put $1 into the account and said, let it go, let it ride. He's doing this again and again and again. So that's gonna be a payment right there. So I'm gonna start writing this out. All right, so he's gonna put $1 into the account, so it's -1, it's going into the bank. -1, he's making a payment. And he's setting aside $1 every day, so he's doing this daily. So our ILM is 365. That's how many times a year he's doing this. That goes in 3 different places. That's our PY and our CY. And our N is ILM times T, so it's 365 times the number of years. Keep reading here. It says earning 4.72% interest, so 4.72. Compounded daily, we did that. He has continued this and is now 35 years old. So he started when he was 8, he's now 35. So 35 minus 8 is 27 years, so that's our time. How much is in the account now? So that's our future value. Okay, so he did not put any money into the account initially and said, I'm gonna start my account with this deposit. He didn't do that. He just started making payments from the get-go. So we're gonna solve for future value to see how much is in the account now. So I'm going to go to my calculator. And apps, finance, TV on solver, and I'll start typing this in. And unless the problem specifically says at the beginning of each one, you just keep it on end. Keep it on end unless it specifically says beginning. So I typed everything in, I put it back on future value, and I'm gonna hit alpha, enter. And so he would end up with $19,922.35. If you put $1 into the account every day for 27 years. But he didn't put all that money in there himself. Some of that is interest he earned. So when it says, how much interest did he earn, we figure that out by saying, okay, he ended up with this future value amount. He put in whatever payment he had in times. So we ended up with $19,922.35 minus, he put in $1 every day for 27 years. And so 19,922.35 minus 1 times 365 times 27. So he made $10,067.35 in interest, which is really awesome because he ended up with $19,000. So he ended up with more interest than he actually had to put in himself. He only had to put in like $9,000, and they gave him $10,000 in interest. Says, given the final simplex tableau below, what is the value of y? So final simplex tableau, anything that has all zeros and one positive number is a pretty column. So x is ugly, x is 0. Y is pretty, all zeros and one positive. Z is pretty, S S1's ugly, S2's ugly, S3's pretty. But we really are only caring about Y at this point. So since Y is a pretty column, and I see the numbers right there, I'm gonna read across row 3. And it tells me 3Y equals 246. And then you divide both sides by 3, you get that Y equals 82. It says Mark and Patrice buy a house for $121,000. That's the price of the house. They pay 15% down. That's gonna be cash. Cash does not ever go in the calculator, ever. So that's the first thing it says, how much is their down payment. Even if it doesn't ask these two first questions, A and B, you've got to find those first every time, no matter what it's asking. So 15% is 0.15 of times 121,000. This will tell us how much cash they put down. And that's 18,150. That's their cash, that's their down payment. That does not go in your calculator. So that's just the answer. And then to find out how much their loan is for, if they paid that much cash and their house costs this much, then the loan amount is for the difference. So 121,000 minus how much they paid in cash. Is $102,850. That's how much their loan is going to be for. So then it says, what are their monthly payments? So I'm going to write down my stuff over here. And we know the loan amount always goes in for the present value. So the loan amount is 102,850. Future value of every loan is 0 because your goal is to pay it off. It says that it is a 30-year loan, so it'll be M times 30, 5.4% interest. And we're looking for monthly payments. So our M is 12. And that'll go in for PY, CY, as part of our N. We're going to be solving for our payment here. So I'm going to go to Apps, Finance, TVM Solver, and I have 12 times 30. 5.4 negative 102. Because you always want to put your present value negative to show direction. Like you owe that much versus you're paying it off, go in a different direction. And then I'll hit alpha enter on payment. And we get the payments are $577.53 each month. So then a common question is, how much interest will they end up paying? So interest you pay is you always pay more than your loan. And so you always do what you pay first. Whatever your payment is times the number of times you're making that payment, minus your loan amount. And so 577.53 is what we're paying every month for 30 years, minus the loan amount. So you don't subtract the cost of the house because you don't pay interest on your own cash. So we have 577.53 times 12 times 30 minus, so 2,850. So end up paying quite a bit of interest here, which is typical for a house. All right. Alright, then it says, after paying on his house for 8 years, how much did he still own on the balance? So this is the outstanding principal. How much you still owe. So you change your N to how many payments have already happened. He's paid every month for 8 years. And then after just 8 years, your future value will not be 0 yet. So you solve for your future value to see what it is, and that's how much you still owe. So we still have all our stuff in here. I'm gonna change my N to be 12 times 8, how many payments I've already made. And then I'll solve for future value, and that's gonna be how much money still owed. So after 8 years, they still owe $89,114.36. So I'm gonna write down all my stuff. Okay, and it says, upon graduating from college, Craig finds he owes $54,700 in student loans. So loans always go in present value. Future value of every loan is 0. Interest rate's 4.2. Compounded monthly, that's 12 times a year. So M is 12. That'll go in 3 places, PY and CY, and N, which is M times T, will be 12 times, guess I need to say how many years, that's kind of a thing. So every loan, you have to pay back within 10 years, so I should have said that. So it must be paid back in 10 years.
So that's how.
Yeah, that'll throw a wrench in if you didn't know that. So 12 times 10, and now you need to solve for payment in order to answer the rest of this question. So we got 12 times 10 is 4.2. Negative 54,700. So you type everything in and then you hit alpha enter and you get that the payment, monthly payment, is gonna be $559.03. So to find how much interest he'll end up paying, that's his payment times N minus what he borrowed. We have $559.03 times 12 times 10 minus the $54,700 he borrowed. So we know he has to pay back the $54,700, but we also know he has to pay a lot more than that because they're allowing him to pay it off over the course of 10 years. And in addition to the $54,700, he'll pay them an extra $12,383.60 in interest for that one. So number 8, Leslie racked up a credit card bill of $8,350. So this is a very high interest rate loan going on here. And so that is a very expensive loan. So negative $8,350 is the loan amount that's under present value. Future value is 0 because you plan to pay it off. This is why it's a high interest rate loan. It's a credit card. So the interest rate is 23% interest. Compounded monthly, that means ILM is 12. And that's going to go in 3 places, PY, CY, and our N, which is ILM times T, will be 12 times however many years we're looking at. It says she can only afford to pay the minimum required payment each month of $165.86. So if the present value is negative because she owes that much and she's going to be paying it off, these need to counteract each other. So one of them needs to be positive and one of them needs to be negative because she's paying off this debt. They're going different directions. If she kept charging $165 a month, it would also be negative, because it would be going toward the debt. Alright, so we were basically solving for N because we were looking for T. How many years will it take her to pay this off? Once we solve for N, that equals 12T. In order to find the years, we will need to divide by 12. Finance TVM solver. I'm going to be solving for N, so I'll come back to it. And I'll type in the rest of my stuff here. I'm gonna put my cursor on the N and hit alpha enter, and I get that N is 176.459167. Divide both sides by 12 to see how many years. So I'm just gonna go over here. I'm arrowing to the right and hit divide by 12, enter. And I get 14.7 years. So once you solve for N, divide that by 12 and you get the number of years. And then so that's 14.7 years. Part B says how much interest will she end up paying? So that's always going to be what you pay, so payment times N, minus what you borrowed, minus present value. So our payment is 165.86 every month for 14.7 years, minus the $8,350 she charged to the card. So 165.86 minus, times 12, times 14.7 minus 8,350. A lot of interest. So $20,907. $0.70. How much interest you would pay. Alright, so C says how much of her very first payment. So her very first payment was $165.86. And we want to know how much of that very first payment went towards paying off the principal, the debt. How much went toward what she owes. So what we do is we change our N to how many payments have happened, which is just 1. And then you solve for future value, and that'll tell you after 1 payment how much she still owes. I'm gonna go back to my finance thing. I need to change my N back to what it was, so I'm gonna hit alpha N on it again. No, I'm not. I'm gonna change my N to 1. How many payments have happened? After 1 payment, she still owes $8,344.18. She owes $8,350. And so $8,350, and after 1 payment, she now owes $8,344.18. So after 1 payment of $165.86, she's only paid $5.82 off of her debt. That means the rest of her payment right here went toward interest. So 165.86 minus how much went toward the debt means $160.04 of her payment went toward the credit card company. Number 9, the Robinson family took out a loan for $20,000. So that's their present value, loan and present value. The future value of every loan is 0. Compounded quarterly, that's 4 times a year. So M is 4. It's going to go in 3 places, PY, CY, and N, which is M times T, will be 4 times the number of years.
So 4.
So they can put in a swimming pool. They're required to make payments of, so they owe this much, but they're gonna be paying it off. So this is gonna be positive because it's counteracting what they owe over the next 4 years, so that's our time. What's the interest rate on the account? So we are solving for the interest rate. So we go to our apps, finance, TVM solver, and we got coming back to solve for my interest rates.
On this one. Because she's ready exactly what we want.
I get all my information in there, and then on interest, I hit alpha enter.
What?
And it says to 2 decimal places, so it's gonna be 3.85%.
Wait, we did like everything like exactly the way you did it, but every time we put
Alright, number 10. William deposits $25,000 into an account earning simple interest. Keyword, right there. It's not a calculator problem, formula problem. And here's our formula. So he deposits $25,000 in there, that's the original amount. At a rate of 3.2%, in decimal, that'd be 0.032. How much does he have in the account? So I'm looking for A. After 21 months, and since time is always in years, that's 21/12ths, because there's 12 months in a year. Then this, I want to put in my calculator. And so we have 25,000, parentheses, 1 plus 0.032, parentheses, 21 divided by 12, parentheses. And he ends up with $26,400. And then it says, how much interest did he earn? Well, he put in 25,000. He ended up with 26,400. So he earned $1,400 in interest.